Recording. Okay, good afternoon, class. Magandang hapon. Okay, so now chapter 7 na tayo. Chapter 7 na tayo ng libro. Page 7 na ito. Okay, and the topic for chapter 7 and the rest of the chapters would be on electrodynamics. Okay? So dynamics na tayo, dynamics. Dynamics na tayo. Okay, so for the past 6 chapters, we studied yung mga ways kung paano natin mahanap yung electric fields and magnetic fields on the assumption that, number 1, yung charges mo don't move, and yung currents mo, they are steady currents, meaning hindi sila nagpa-fluctuate. Okay? So now, in electrodynamics, what happens when we move charges or when we fluctuate currents? So, ito yung pupuntahan natin ngayong topic. Okay? So, ngayon, hindi na tanong dito kung ano yung mga magnetic field at electric field. No? Dapat alam na natin kung paano kumuha ng electric field at magnetic field. Okay? Okay, so, first things first, let's try to move charges. Okay? Ohm's law. Ohm's law tayo. Okay. So, Ohm's law, sinabi na yung J, the current density, volume current density J, can be written as sigma F. Okay, itong first equation. So, F is, breakdown lang natin to. Ayan yung lumipat. Okay, yung F ay force per unit charge. Okay? Sigma is not current, is not charge density, but it is a conductivity. Okay? Conductivity yan. So, nagbabago yung conductivity per material. Okay? And then, yung conductivity for metals, mataas. And then, yung sa mga insulators, mababa. Okay? So, in essence, may current na nagpo-flow sa insulators, no? Kaya, ayun yung difference natin with normal people. Normal people would assume totally na, ay, walang nagpo-flow na current sa, di dumadalo yung kuryente sa, sa insulators, no? But, mathematically, physically, kung titingnan natin yung mga equations natin, yes, it would flow, current would flow through your insulators, but mahinang-mahina kasi mababa yung conductivity. Okay? Okay, so remember that. Kaya natin in-avoid yung paggamit ng insulator. Okay, kasi meron siyang apparent meaning to our brains, no? Parang, ay, pag insulator, hindi na dumadalo yan. So, we prefer natin last time is dielectric para fancy. Okay? So, avoid natin yan. Avoid natin. Okay? Okay. Now, F, we know the force is force due to a magnetic and electric field would be Q times V, E, plus yung QV cross V. Okay? So, ito yung magnetic factor and magnetic. And this one is electric, di ba? Okay? So, QE is your electric force. And then, ba't may Q pa dun? Wala na tong Q, syempre. Pinactor out na natin. Okay? So, yung QV cross V is your magnetic force. Okay? Yung V yung velocity lang ng charge. And then, combining all of this, yes. Yung J ay volume current density pa rin. J is current pa rin ito. Okay? Yung nagbago lang yung right-hand side kasi yung F, may isang definition tayo ng F dati, electrostatic pressure, which is force over area. Okay? And then, yung sigma natin dati is surface charge density. Okay? So ngayon, iba yung definition natin. Kasi maubusan na tayo ng mga letra. Uulit na yung mga letter natin, no? Guys, maubusan na tayo ng mga letter. So, kailangan natin mag-reuse ng mga letra. Okay, kaya ayun yung sinasabi ko sa exam nyo na always define your constants. Okay? Okay, so going back, combine natin tong dalawang to. So capital F is your force, total force, and small f will be force per charge. So tatanggalin mo lang yung charge, ayun na siya. E plus V cross B, then your sigma, which is your conductivity. So Ohm's law is really this guy. Okay? Hindi V is equal to IR. Ito yung legit na OG na Ohm's law, guys. Ha? Si Joe. Joe. Okay? J is equal to sigma E. Okay? Okay, so let's try an example. Okay. Okay. So, example 7.1. So, sa chapter 7, napakaraming example. And there's a lot of discussion going on. So, you can go and read those. Masaya naman basahin si Griffiths, guys. Actually, si Griffiths lang yung pwedeng for leisure na reading. Kasi may sense of humor siya. Okay. And gumagamit siya ng mga normal words for normal people. Tapos mahilig siya magawa ng mga italics na ganyan, na gusto niya ng emphasis. Di ba? Parang saya-saya basahin. Napaka full of emotions. Okay, so continue. A cylindrical resistor of cross-sectional area A and length L, okay, given say area, length L, is made of material conductivity sigma. Okay. Okay, so yung A mo, not necessarily circular, but ina-assume na homogeneous in terms of length. Okay? Bale, hindi siya curve with respect to Z. Okay? All through Z, same yung cross-sectional area mo. Okay? If we stipulate that the potential is constant over each end, and the potential difference between the ends is V, what current flows? Okay? Okay. So here is your potential. May potential ka daw dito, VA, VB. And then sabi niya, yung potential difference lang naman daw is V. Okay? So constant yung potential difference, V. And ano yung definition natin ng potential? Di ba E dot DL? Okay. Okay. This is a rough calculation. Okay. Pero pwede niyong pahirapan sarili niyo na pumunta kayo sa Laplace equation, but this would work. Okay. How do you produce a constant V? Di ba yung DL mo, which is yung L length, total length is L lang lagi for this case. So kung meron ka ng V, L, what factor would you add to make it constant, di ba? To make constant V, hindi dapat constant E lang din. Okay. Constant E lang. Parang sarandaya niya na. Well, in essence, ganun lang, no? Pero pwede kayo mag-Laplace equation. Okay? So, yung E mo is just V over L. Okay? And then, ano kailangan natin? Si Joe. J, sigma, E. Okay? Okay, so J, sigma, E. Para makuha ko yung total current, multiplyan ko siya. J times, di ba ang J ay current per area? Tama? Tama. Current per area. So if I multiply that with A, sigma A, E, then I get the total current I. So I has to be sigma A. Plug in natin si E, which is V over L. Okay? And yung direction niya would be parallel sa kung saan yung E. Okay? Okay. So, direction ng ito. So, lagyan natin ng E hat. Ang daya. Okay. Ang gusto ko lang i-point out is what is this. So, kunin lang muna natin yung magnitude. Sigma A over L V. Okay, di ba ganyan? And if we are going to rewrite this nicely, V, lipat natin yung, iwanan natin si V sa isang side. So, L over sigma A I. Okay. Now, yung sigma, yung conductivity, usually hindi yan ginagamit. Ang ginagamit for calculations would be resistivity. So, resistivity, rho, confusing, di ba? Kasi rho is your volume charge density. Okay, it's just 1 over sigma. Okay, rewrite natin in terms of resistivity ito. So, yung 1 over sigma is just rho. So, this is just rho L over A. Okay? Times I. What is rho L over A? Kung napuntahan nyo na yan sa dati yung physics courses, this would tell you that this is your usual formula for cylindrical wires. Well, actually not necessarily cylindrical. Basta for wires siya. No? And then rho L over A is usually written as your R, resistance. So this, the right hand side is I R. And amazingly, ito yung mas alam nating formula for Ohm's law, which is V is equal to IR. Okay? So diyan pala napaulit yun, no? Okay. So pwede niyo prove na ito yung potential ay yung electric field in the region between this. So nasa libro yan, example yan sa libro kung paano niya pinrove na this is just tawag dito, constant. Okay, so yung parang sagot dyan ay negative Vz over L. Okay? Z hat. Ay, walang ano. For the potential ito. V not T. Okay? So, potential ganyan. Kukunin mo yung gradient ngayon, mawawala yung Z, makukuha mo V over L. Okay? Okay. Okay, so yan. Okay. Goods na tayo. So, ayun, doon napulot yung V is equal to IR. Essentially, kapag gumawa ka pa ng other problems, malalagay mo siya to some always like this. So, V is linearly related to I. You double the potential difference, you double the current. Okay. Okay. Okay, may mga questions tayo regarding kung pinag-isipan nyo itong mga currents na ganito, yung mga circuits mo, isipin mo lagi. Okay. Number one, isipin natin, you have a bulb, you have wires, then you have a battery. Okay. Suppose tanggalin mo muna si wire. Then, pag kinabit mo, at the instant you connected the wire to the battery, magugulat ka, biglang iilaw na agad yung bombilya mo. Okay, so that's one. Bakit ang bilis, no? Gaano ba kabilis yung current down the wire? If you are gonna calculate for that speed, kung gaano kabilis yung current mo, malalaman mo na kasing bilis snail's pace yung bilis ng mauunahan pa nga ng snails ata yung bilis ng current. Okay? Pag tinignan mo kinalculate mo, nasa problem 5.20 siya. Problem, if you're very curious about it, 5.20, malalaman mo na ang bagal ng current. Okay, so pagka-plug in mo, yung ilaw na agad. Okay, that's one. Then, if you wrinkle the wire, may ipit ba yung current doon? Mag-fill up pa somewhere? Okay, so yung mga questions na ganun. Tingnan natin kung paano natin masasagot. Amazingly, yung sinasabi kong pag-bend ng currents, okay, pag binend mo na, kunyari itong current, okay, binend natin to the right. So, assume natin na yung I in lumalaki. Tapos yung I out kumukunti. Ayan, makikita nyo na mas makapal yung I in, I out. Kasi parang isipin natin intuitively, pag binend mo yung current, di ba parang mapipigilan mo yung current from the other side. Parang hose ng tubig. Pag binend mo yung hose ng tubig, di ba, on the other side, parang mag-fill up siya, ganun. Okay, so what happens? Amazingly, when you do this, kung assume mo na ganito yung nangyayari, magpa-pile up yung charges along the bend, kung saan mas malaki yung bend. And this charges would pile up, tapos magpo-produce siya ng sarili niyang electric field. Now, amazingly, kung titingnan mo, pag nag-produce to ng electric field, kukontrahin niya yung current na yun, and papalakasin niyo yung current on the other side. Okay? Amazing. So, in essence, nagiging uniform yung current all over the wires. Okay? Okay. Nice. And then, paano yung isang problem natin kanina? Bakit ang bagal-bagal ng current? Well, pag isip natin yung wires, kuwari ito yung surface ng wire. Siyempre may mga molecules ka dyan. And then, kung imaginein mo, may mga umiikot na charges dyan. Yung nagre-revolve ng mga charges. Tapos yung calculation sa 5.20, we just calculate the charge that is going through from left to right. Pero yun nga, nakita nga na mabagal. Pero kasi ang yung importante dito is yung macroscopic view mo. Kung isipin nyo, meron kang charge na gumagalaw dito. So yung small movement nila, it seems like transport ka ng mga bagay-bagay, pero onti lang ginagalawan mo. Okay? So yung collective action nila yung important, yung nakikita natin current. Okay? Okay, so yun lang, mga bagay na isipan natin. So hindi ba kayo nag-wonder bakit J sigma E? Tapos, sir, di ba akala ko ba walang electric field inside the conductor? Akala ko ba walang walang electrostatic field inside the conductor, guys, okay? So yung mga motion ng okay lang may mag-flow na current, but not yung electric field mo inside the electrostatic field inside mo na conductor, zero pa rin naman. Pero it does not necessarily mean that the currents would zero. Okay? And if charges would reside on your conductor, as before, nasa surface lang siya. Okay? Okay. Going back. So, ipunta natin ngayon yung electromotive force. So, what makes the world go round? What makes the charges go around here? Okay? Okay. So, di ba ang force ay QE? So, pwede natin sulat yung force as E. Okay? Nasabi ko ba kung bakit nawala yung dito? Hindi kayo nagtatanong. Nasabi ko ba kung bakit nawala yung V cross B dito? Nasabi ko ba? Oh my God. Am I going too fast? Anyone? Hindi ko pala nasabi. Okay, sorry. Natuwa ako dun sa original J sigma E as the OG Ohm's law. Okay, sorry. Yung V cross B, nawawala ito dahil usually inside the materials, inside the wires, inside the metals, yung B mo is relatively weaker than E. Okay? Okay. So yung mga materials na ganun, yung mga bagay na ganun wherein this is true is called ohmic materials. Okay? Okay? When this does not hold, hindi nagagana, hindi na sila tinatawag na ohmic materials. Okay? Okay. So, V cross B, zero lang to dahil mahina yung fields, magnetic fields compared to your electric fields. Okay? Okay. Okay. May instances syempre naman na meron talaga tong V cross B, okay? For plasma na materials, merong V cross B. Kasi sabi nga natin yung isa ring factor din yung mabagal nga yung mga charges sa loob ng isang material. Kaya maliit yung V, yung speed, maliit din yung magnetic field. So in essence, parang nagiging zero out lang to. Okay, so sorry, nakalimutan ko. I was so excited to say that this is the OG Ohm's law. Okay, okay. Going back. Okay, so ano nagpapatakbo ngayon sa tawag dito? Sa charges mo. Okay. So, yung force mo would be, of course, force per unit charge is just Fs, which is the force due to the source, battery, whatever, kung ano man nakakabit dyan on one side, plus the other electric fields that are pushing your charges around. Okay? Okay, so now, yun natin. Wait lang. Kung titingnan natin yung isang circuit, we can actually get, sorry. Okay, we can actually integrate this whole thing across a loop, f.dl. So ito ay mga vectors, ha? Sorry, hindi ko nalagay. f.dl, and then do the right hand side, the other term. Okay. What is this, guys? Zero lang to, di ba? Naalala nyo dati for electrostatic fields. Okay. So the electromotive force, we can define it as yung epsilon, capital epsilon. Tapos ito ay ito. Ayan. F.dl or from the supply itself, from the source itself. Fs. Okay? Kasi wala namang contribution yung E.dl. Okay. Okay. This is for electrostatic fields. Okay? Mamaya may madadagdag dyan. Magagamit pa tong bagay na ito. Okay? Okay. So, remember that this is just electrostatic fields. Okay? Carry. Dali lang, di ba? So, ayan yung electromotive force mo. Ayan, this kind. Ito na sinulat pala. Para tayo mahirapan. Okay. Kapag yung source mo ideal, ano ibig sabihin ng ideal source? Kuwari battery. Ibig sabihin walang resistance yung battery mo. The current just flows through perfectly there. And what happens is that we have this equation na Fs mo would be just the negative of the electric field that is supplied by your source. Okay, this E is not same as yung E na nawawala. Okay, ito ay E due to the battery. or the source, or whatever source that is. Okay, so yung electromotive force mo, you can now write this as your, diba, ito ay Fs.dl, and if you're gonna write down, sulat mo, plug in mo ngayon si E, and then between the terminals of the battery, ang mangyayari is that, syempre, pag sinarado mo pa rin yung battery, magzi-zero out pa rin to, okay? Ang point is, lilipat mo ngayon yung isang end sa battery mo, okay? So, yung terminals to ng battery mo. And this is just our formulation for the potential, okay? Ay, sumulat. This just our formulation for the potential. Amazing. Okay. So, yung nagpapatakbo ngayon sa current mo, circuits mo, is just kung yung electromotive force, and we found out that whenever your battery is a resistance, ideal battery siya or resistance-less na supply source, ang mangyayari is just yung electromotive force mo would be equal to the potential difference between the terminals. Okay? Okay. So, yan. So, yun ang electromotive force. Okay, so yung electromotive force, it's just ito yung nagpapatakbo sa circuits mo. Now, let's do this thing. What happens when we have a wire, circular loop of wire? Yan. May resistance ka dun sa kabila. Let's say, pwede itong bumbilya. No? This can be light bulb. Okay? So, whenever you have an object that is consuming energy, pwede mo siyang isulat as resistance lang. Okay? In some terminologies, tinatawag itong load. Okay, wala lang, terminology lang. Okay, so we have this loop of wire. And what happens now if we move this whole wire towards the right with velocity v? Okay, now sa wire mo, may mga charges ka dyan. All over it. Okay? Okay, so mayroon ka mga charges all over there. And then yung ano mangyayari kapag itong wire na to is under an influence of a magnetic field, which, let's say, points into the page. Then you move this whole loop towards the right with velocity v. Okay? So, tingnan natin, di ba meron tayong force due to a Q V cross B. Okay? So, whenever your charges Q have a velocity V, and the whole thing is under an influence of a magnetic field, meron kang force. Okay? So, yung mga affected lang would be on this guy. Okay? Okay. From C to D, walang charges. So, wala yan. However, from D to A to B, B to C, meron kang charges. Okay? Okay. Tingnan natin ngayon yung charge dito sa baba. Okay? Charge dito sa left, charge dito sa taas. Sa baba, yung sa A to D, maraming charges dyan, but tingnan natin, yung beam mo, this goes this way, and yung beam mo is into the page. Okay, into the page yan. So V cross B is really upward, right? So V cross B, okay, if you do the right-hand rule from V going to the magnetic field B, ang makukuha mong force is upward. Tama ba? Okay. So that's for all charges, ba? Lahat naman sila going to the right with the velocity V. Okay. However, dito sa segment na A to D, they can't go up. Kasi nandun confined sila dun sa wire, di ba? Hindi sila makakaakyat. And same goes with the segment B to C. They won't be able to go up. Tama? Kasi confined sila dun sa segment na yun. However, sa segment from A to B, they can go up right now. Okay? So may force na nararamdaman tong segment A to B, and that force pushes the charges and in essence makes a current on your loop or in your loop. Okay? So calculate nga natin to. Calculate natin. Okay? Yung V cross B, normal multiplication na lang siya. Kasi yung V mo to the right and B mo, the magnetic field is into the page. They're already perpendicular with each other. So VB na lang. VB. Meron kang QVB. Okay? QVB. Tapos, okay. So we have this as your force. However, ang kailangan lang natin is this guy. Diba? Yung Fs natin or F in essence. Kasi ayun lang naman yung hello, choppy ba ako? Check mark or X mark? Sorry. Nag-prompt sa akin na mahina internet. Okay. So we can continue. Kunin natin to. So E is just integral of Fs at dl. Okay? We know dl is upward. So lagay na lang natin na and yung Fs natin force is upward. So paano ba? Kuha na lang tayo ng direction na z hat for upward. Okay? Okay, so z hat to, z hat dotted with the dl, z hat din. So they are parallel already. So dl mo, what is dl? If we complete the dl here, the length of A to B is just h. Fs h, and then we have Fs to be VB h. Okay? Okay. Now, we can further generalize this to an arbitrary shape and arbitrary direction of velocity. Okay? And to do that, we need the flux. Gamitin natin yung flux. Ang flux is defined to be this guy, phi, the capital phi. Capital phi. Tapos, integral ng B dotted with dA. Okay? Okay. So, gawin natin to. Try natin gawin to. B dotted with dA. Kunin muna natin yung phi. Phi. In this case, you have B is given. Okay? B is given and we know that dA, this guy. Okay? Pwede tayong mag-isip pwede natin isipin na into the page or out of the page yung direction ng dA, itong area na to. But for simplicity, gawin na lang natin na B.dA is a positive quantity. Tama? Kasi pwede naman natin sila align. Okay? So B times yung area. My area would be H times X. Okay? Kung gaano man kalayo ito. So BHX Okay. And then, let's get the change of the flux in time. Okay, kasi si x mo nagbabago through time, di ba? As you move v. So let's just get the dh, dx over dt. Okay. Is the change in positive, is the change in x positive or negative? So x is decreasing. So dapat yung dx is a negative quantity. Okay, over time. Okay? Kasi as you go along the right direction, lumiliit yung area mo, lumiliit yung length x mo. So, yung dx has to be negative. And alam naman natin yung dx over dt will just be your velocity v. Okay? So, we can write this down neatly. Okay? So, ito ay nakuha na natin to, which is just the electromotive force. And we see that dv over dt is just negative of the electromotive force. Or mas maganda kung ganito. Okay? Okay. Nice. You have that. Okay. Okay, what else do I need to say? Okay. So parang ang ano naman ang legit ba yan for all kinds of things? Okay, so may general proof to kay Griffiths. Na kung gusto niyong gawin, pwede. You can read that in your free time. Pero wag natin daanan ngayon. Okay? Nasa libro yan. Nasa libro yung general form or general derivation or proof for that. Okay, continue. Let's try an example na para hindi naman tayo lost in life. Okay, example 7.4, a metal disc of radius A rotates with angular velocity omega. So yung omega mo is this guy. Okay, so nag-rotate siya counterclockwise when viewed from above. And then a uniform field is in z hat, pointing up. Okay, sabihin na lang natin z hat yung up. And then the circuit is made by connecting one end of the resistor to the axle. So yung isa nandito sa ilalim, dun sa point of rotation niya. And then the other one is in the edge of the disc. Okay? So, ano yung pinapakuha sa atin? Okay. First things first, kunin natin yung V cross B. Okay? V cross B. Kunin muna natin ito para tayo mahirapan. Alam natin na yung V ay can be written down as wait lang guys, nagloloko yung panulat ko. Okay, nagloloko yung panulat ko. Let's do this. Ay, ayaw magbura. Yan. Okay, going back. Sorry. Yung B mo upwards, so Z hat sabihin natin. B is in Z hat. Tapos, yung V mo can be written down as S omega. S is a distance from the center. Okay, your usual cylindrical coordinates. S is omega. And we know that V is always perpendicular to B. Okay? Okay? Okay. So we have in essence is SW B. That is for your, that is F. Okay? SWB. Laro ba dun? Now we have to integrate. This guy, yung S omega B mo. Kasi di ba yun yung definition natin ng electromotive force. Okay, so let's write them down. Yung DL mo, what is DL? Yung DL mo ngayon would be from here, from the center to the outward radius. Okay? Okay, kasi kung titignan nyo, kumari, at this point, ito yung, this is S. At this point, pag ganun yung V, tapos yung magnetic field mo is upward, B. So V cross B is in this direction. Radial direction yung radial direction yung force mo. So we have to integrate along the radial component. So we have omega B, integral na S, ds, and we just have to integrate all over the disk. So that is 0 to A, kasi radius niya A. Okay, dali, di ba? So this is just omega B, A squared, okay, over 2. And what is the current that flows? Ang tanong kasi sa atin, di ba? Find the current in the resistor. The current in the resistor would be the electromotive force divided by the resistance. dA squared over 2R. Okay, dali, di ba? What's the direction of the current? Direction of the current will come from yung mga right-hand rule na ginawa mo. Kasi di ba dito napansin natin na to the right yung direction ng charges due to the magnetic field and the rotation of the disk. So, ibig sabihin, kung papunta sa kanan yung charges na yun, it must go down in this direction. Okay? Okay. So, we have that. Okay. Hindi ko pala nasulat, no? What is the power that is running through, feel ko alam niya naman na ito. What is the power that is flowing or in the circuit if there is current I and resistance R? So yung power mo would be, actually, mas gamitin natin yung potential and yes. Yung potential and given potential and the current, your power is actually V times I, or if you write down I as V over R, then we have your V times V over R, which is your, alam nyo na to, V squared over R. And then if you're gonna write down V as IR, then you have IR times I, then you have I squared R. Okay, wala lang, for fun, kung gusto niyo malaman yung power that is in the circuit. Okay, so additional lang. Okay, now, okay. This, tingnan natin ngayon, yung what else can we do, no? Kasi nakita natin dito, ginalaw natin yung loop. And then may umikot na current. Okay? So, in essence, kung light bulb ito, In reality, if this was the light, if this is a light bulb, and you pull, hinatak mo yung loop, iilaw yung light bulb na yun, amazingly. And ginagawa to ng mga, or baka ginawa nyo as a grade school student, yung magnetic induction, di ba? Parang, okay, so what else can we do? So, punta tayo sa mga experiment ni Faraday. Okay? So, experiment 1. He pulled a loop of wire to the right through a magnetic field. Okay, and a current flowed in the loop. Okay, so ito yung tinignan natin kanina. May loop ka daw, hinatak mo away from the magnetic field or through a magnetic field. So that's experiment 1. Now, experiment 2, ginawa niya. Okay. He moved the magnet to the left, holding the loop still. Again, mayroon kang current. So, ang ginawa niya naman niya, reverse nung system natin. Naka-steady si loop, then inusog mo yung magnetic field. Okay? Now, experiment 3. So, sabi ni Faraday, ay, obvious tong experiment 1 and 2 ko. Siyempre, relativity lang to, di ba? Kung anong ginawa mo nung yung point of view ng isa, point of view lang din ng isa. So, binaliktad mo lang, parang ganun. Okay, parang intuitive naman yun. So, experiment 3, ang ginawa niya, yung loop ni parehas at yung magnet, parehas yun, naka-steady. Okay, so hindi gagalaw. Ang gagawin niya ngayon, tataasan niya yung magnetic field. So, ang gagawin niya lang is you wrap around the current sa electromagnet mo, then lalaksan mo yung current mo, di ba? Kasi ganun yung parang solenoid mo. Okay, so electromagnet. Then, napansin niya, same thing yung nangyari. May current ka na nabuo sa loop mo. Kahit wala kang sinusupply na kuryente. Okay? So, yung magnetic field lang yung magnetic field lang yung binago mo. So, in tawag dito, in pictures, ganito yung experiment. Okay? So, number 1, experiment 1, you move the loop away from the magnetic field, then boom, may current. Now, you move the magnetic field and steady yung current, steady yung loop, then boom, may current ka. Pangatlo, steady lahat ng system mo except that you're changing now the magnetic field, then wow, meron pa rin current na umikot dun sa loop mo. Okay? So, naisip ni Faraday, changing magnetic field must induce an electric field. Okay? Okay. So, paano ba ito kinuha? Let's try to solve that. So, what do we know? What do we know so far? Balik tayo sa mga definition natin. So, we have the electromotive force as the negative derivative of time of the flux over time. And this is just your negative integral of nalagyan natin derivative sa labas. Para neat. B dot dA. So, yung B dot dA, that is just your flux. Tama ba? Okay. Since yung dA mo, that won't change over time, but the field can change over time. So, we have B, D, D, A. Okay? Okay? I forgot the vector sign. Okay, we have this, and then yung E can be written down as close integral of E started with dl, and your right hand side would be the flux, derivative ng flux, that dA. And then Stokes theorem. Naalala niyo pa yung Stokes theorem for this? Okay, so malilipat lang yung dl to dA. Okay, so ang trade-off nun would be you need the curl of E, that is with dA, and then the right hand side is still the same as dA. Okay? Same yung integral .dA. Therefore, we have these two must be equal. The curl of E now is nice. Okay? That's nice. Okay, kung naaalala nyo sa electrostatics, we know that del cross E is just 0. Pero now we're no longer using electrostatic fields. Okay? So yung field yung magnetic field can change, therefore this is non-zero. So we have this term. Okay? So that is Faraday's law. Okay, isang example in your book, a long cylindrical magnet of length L, radius A, carries uniform magnetization parallel to its axis. Okay. So, gagraph daw natin yung EMF induced in the ring as a function of time. Okay? So, yung whole cylinder mo will go inside this loop. And then what happens to the EMF? Tingnan natin yan. Okay, the magnetic field for this setup, for this cylinder, we have B. In the axis of the magnetization. Mu M, di ba? Mu M. However, if you're looking at this side, this is just B, mu naught M. Okay, kasi outside wala namang magnetization doon. Therefore, the field na nararamdaman nitong side na to is mu naught M. Okay? And then the flux would be simply mu naught M times pi A squared. Tama ba? Okay? Kasi A yung laki nung A yung laki nung cylinder. And sinabi natin yung ring ay slightly larger diameter. So in essence, pwede na sabihin na same lang, A. As long as it would fit. Okay? So we have this flux. Okay, so this is the maximum flux. If you throw the cylinder away very, very far, wala kang makakuha flux dito. Syempre, wala namang magnetic field. And then, the maximum, kapag nilapit mo siya dyan, ito yung makukuha mong maximum. Okay? So, let's graph that. So, yung graph nito would be this guy. Okay? So, this is flux versus time. Syempre, kapag malayo pa siya sa loop mo, there will be no flux kasi wala mararamdaman na magnetic field yung ring. So, B0. And then, kapag nilapit mo na siya, you have, maaabot mo yung maximum mo, which is mu naught M times pi A squared. Okay, calculate natin yan. Now, mag-stay siya doon. Okay? Kasi ayun din yung field dito sa loob, diba? Medyo ayun. Kasi may mu, pero sabihin natin almost equal sila. Okay? And then mag-stay siya doon sa region na yun with, of course, time is L over V. Length divided by velocity. Kasi gumagalaw to ng velocity V. Okay? So, length, velocity, this is just time. Tama, di ba? Kasi ito ay x over t. Pero, ano lang to yung dimensional analysis. So, magka-cancel yung length. And tama, it must be this amount of time. Okay? And then, E, the epsilon, is just the negative ng derivative ng phi with respect to time. Okay, so whenever phi changes in time, negative nun would be your epsilon. Okay? Kailan walang change yung phi? Kapag straight line. Straight line. Straight line. Okay? Yung change dito is rising, so it's positive. but you have to negative it down. So you have this. Okay? Okay? So yung change dito is pataas. Then change dito pababa. Okay? Diba? Pataas. Then from pababa. Kaya ganun yung nakuha ng graph. Okay? And then the other one, nakakalito yun kasi may negative kasi do ka bad trip kaya nakaka siya, na-confuse siya. Okay? So the other one, bababa muna siya then tataas. So kung i-graph mo yun normally, bababa muna siya then tataas. However, negative nga. So nag-flip to papunta dito. So you have this graph for your EMF. Okay? Okay, we have that. Now, again, sinabi ko nga nakakalito itong mga direction. Paano ba natin kukunin yung direction na yan? Okay, so Lenz's law tells us that nature does not like change in flux. Okay? So, pwede mong gawin is you get the electromotive force, just the magnitude of it, then plug in later on the direction of the current. Okay? So, pwede mong gawin yun. So, tingnan natin ngayon kung paano natin ma-apply itong nature abhors a change in flux dito sa example na to. Okay? Okay. Tingnan natin. Drawing muna natin yung magnetic field nitong bagay na to. Pag drawing mo yung magnetic field nitong bagay na to, ganyan siya. Okay. Ganyan siya. Assuming nyo na lang maganda drawing ko. So, in this side, pag ganun pa rin. Yan. So, ito yung itsura ng magnetic field nito, no? Okay? Not very pleasing to look at. Okay, suppose na isipin nyo muna na wala tong material natin, yung magnet natin wala. So, yung flux na nararamdaman nitong ring is zero, tama ba? And then, kapag nilapit mo yung magnet mo, magkakaroon ka ng increase from zero to something, some constant C. Now, nature does not like a change in flux. So, yung flux mo, increasing from zero to C, and nature does not like that. Okay? So, anong gagawin ng ring? Ang gagawin ng ring is magpo-produce siya ng sarili niyang flux to counter the change that is happening. Okay? So, the electromotive force is negative. Therefore, yung rotation ng the induced rotation for this loop of wire is going clockwise. Kung titignan mo dito, drawing natin yung mata. Okay, kung titignan mo dito, ang mangyayari sa wire mo is magkakaroon siya ng current na clockwise. Okay? And if you do the right-hand rule for this current, you'd see that the magnetic field that it points is going this way. So kina-counter niya yung flux na nagbabago. Okay? So from 0 to C, ibig sabihin no, tumataas yung nararamdaman ng ring na nararamdaman na flux ng ring. So in essence, ang gagawin niya, kukontrahin niya yun. Therefore, magpuproduce siya ng clockwise current to produce a magnetic field and therefore counteract that increasing flux. Okay? Now, what happens if... Okay, so ayun yung ibig sabihin ng ayun yung ibig sabihin ng negative na negative na electromotive force dito. So, mahirap kasi isipin, ano yung negative na electromotive force? Ang direction yun. Okay? So, the Lenz's law would tell you that thing. Okay? Kung paano niya ini-induce yung electromotive force in this circuit. Okay? Or in this loop of wire. Okay. So, pag natapos na dumaan yung magnet mo, anong mararamdaman nung ring? Mararamdaman nung ring na iniiwanan na siya ng mga magnetic field. Okay? Nababawasan na ako ng magnetic field. So, ayaw ng nature yon. So, ang gagawin ng magnetic field, ang gagawin ng loop, is magpo-produce siya ng current in such a way na dadagdagan niya yung nawawalang field sa kanya. Okay? Nakakaramdam kasi siya na nawawala na siya ng field. So, ang gagawin niya, mag-i-induce siya ng field para madagdagan siya ulit. Okay, how do we do that? Pagpapaalis na yung burahin muna natin itong mga bagay-bagay dito para tayo malito. Pagpapaalis na yung magnet mo, nawabawasan na ito ng field. Therefore, ang gagawin niya is produce a graph muna natin. So, isipin nyo, nandito na yung magnet. Ito yung dulo ng puwet ng magnet. Ito yung puwet ng magnet. Yan. Okay, so, yung magnetic field is here. Pag ganun. Ay, sorry. Okay, pag ganyan yung magnetic field. So, nangyayari, may nauubusan si loop ng pagantong field. Therefore, it needs to supply its own na paganon. Okay? And to produce this magnetic field, ang kailangan mo na loop doon would be counterclockwise, right-hand rule. The right-hand rule will go counterclockwise. Okay, so yung mai-induce na loop would be counterclockwise this time. Okay? Okay. Para mag-produce siya ng field na tinatanggal sa kanya. Say again, nature does not like change. Okay. Okay. Makita mo to ngayon dito sa graph mo ngayon. Kasi nag-flip ka ngayon eh. Therefore, magkaiba yung direction ng current induced dito, iba rin yung direction ng current that is induced here. Okay? And it checks out. Nung una, clockwise. Yung pangalawa, counterclockwise. Checks out. Okay? Okay. So that's that for Lenz's law. Okay? There are marami pang examples ng Lenz's law or in different cases, di ba? Okay? So nakakalito yung baka lumabas to sa exam, no? Na ano yung direction ng current induced, ganun. So let's try another example, the jumping ring demonstration. So if you wind a solenoidal coil around an iron core, okay, so yung iron ay pampataas lang ng magnetic field. Kita natin yun dati sa example natin, ay nun sa formulation natin ng magnetic fields in matter. And then we place a metal ring on top. Tapos plug in natin yung solenoid natin. Yung ring will jump several feet in the air. So pwede kang gumawa ng barrel dito, no? Nakakalsik yung ring. Okay? Okay, so drawing natin yung yung loop. So yung current mo will go like this. Tama ba? Okay? So, t-hat direction. Okay? Kung ito ay z. Okay? Okay. Now you have a ring. Then, what is the magnetic field that is produced by this? If you are going to turn on the current. Therefore, from 0, magkakaroon siya bigla ng whoop, ganun na magnetic field. Okay? So this is your B. Okay? And again, nature does not like that. So dun sa loop mo, sa loop of wire, ang gagawin niya, it would require, nature would require this loop to produce a downward magnetic field to counteract the change, di ba? Kasi from nothing, bigla siya nagkaroon ng magnetic field going inside it, and nature does not like that, so kukontrahin niya. And to produce this kind of current, ang gagawin ng loop mo is to have a current going in that direction. Okay, by the right hand rule. Ayan. Okay, so if you're negative phi hat direction yung current. Okay? Okay, so ayun yung mangyayari. And then, why does the ring will jump? Okay. Just like electric field and magnetic, just like electric field, yung magnetic fields mo won't cross. Okay. So itutulak nila isa't isa. Pero again, you can calculate the force using F is equal to I dl plus P. Okay? But anti-parallel loops, anti-parallel currents would produce repelling magre-repel yung dalawang naisip ka ng current na ganyan. Okay, pag may current ka na pa ganyan, current ka na pa ganito, the force is repelling. Okay? And if you're gonna do this a loop, ganito yung mangyayari. Okay? So, ayun. They will repel each other. And violently. Yes, violently. Lalo na pag mataas yung change in current. Okay? Amazing. Now, for things that, let's say that in our examples, the electric field is totally induced. Totally induced. Okay? What does that imply? Yung del dot E mo, di ba, del dot E natin is your Gauss's law. And this is never non-zero. Okay? So this is rho over epsilon, na kung naalala nyo. Okay? Ngayon yung Gauss's law natin. However, when rho is zero, that is no charge, bale, yung electric fields mo is purely from magnetic fields. Okay? Changing magnetic field induces an electric field. Kung ganun lang yung electric fields na present sa'yo, then the equations would change. Yung del dot E mo is now zero. And del cross E, calculate natin, which is Faraday's law, is, of course, the change in magnetic field in time, which is this. Okay? Okay? What now? Kung titingnan natin yung mga equations natin sa magnetic field, is this guy, di ba? Okay, and what equations arise from this? So meron kang B sa var, and then Ampere's law. Okay? You have from these equations, sumusulpot yung B sa var mo, and then Ampere's law. Siyempre, kung nangyayari yun dito, mangyayari din dito sa electric field mo. So therefore, yung electric field mo ngayon can be written down into some complicated things. Okay? Magiging Biot-Savart na siya. Okay, ayan. So meron kang Biot-Savart na, oh no, na equation. Okay? You have this. And then, if you are very lucky enough, you can write this down in terms of the Ampere's law. Okay? So, paano ba yung Ampere's law for this guy? Diba, ang B dot dl, B dot dl is just mu not I enclosed. Okay, so if we pattern this guy, oh no, naglalag yung ano, sorry. Okay, if we pattern this guy, to your electric field, okay, sulat muna natin yung B.dl. Mu not J dA. Okay? So, kung ipapattern natin to, mu not J yung sa B, yung sa A will be negative partial of B with respect to T. So, in essence, if we're gonna write this down in patterns, this is partial of B, partial T, dot dA. Okay? And B dot dA, we know that that's just the flux. The total flux. Okay. So, yan. Kaya siya na-produce na ganyan. Okay? So, ito ay parang Ampere's law. You can do this for Ampere's law when just the right-hand side is the change in flux. Okay, let's do this. Example tayo. Meron kang uniform magnetic field upward. And yung shaded region is this guy. If B is changing with time, what is the induced electric field? Okay. Now, yung E mo, di ba, pinag-aralan natin yung curl, kung paano yung direction ng curl. Okay, so when you have, balikan natin para hindi naman tayo, you have this equation. Wait, ayaw gumana ng panulat ko. Ay, sorry. When you have this equation, di ba, pag may J ka na ba ganun, yung magnetic field mo would be the right-hand rule. Okay? So in the same way, if we have this guy, when you have a magnetic field going this way, your electric field should curl around your magnetic field. Ay, sorry. Okay. So you have that. So isipin natin dito that the electric field actually rotates around your magnetic field. Okay? So gamitin natin, since min symmetry tayo, gamitin natin to para mas madali. Okay? E.dl. Again, yung left-hand side is always a variable, 2 pi s, which is yung Amperian loop mo. Okay? 2 pi s is just the circumference. And then the right-hand side would be ddt ng flux. Okay. So, yung flux mo, d t times pi s squared. Tama? And yung s, hindi siya tatablan ng t. Derivative with respect to this. Therefore, you have the e as negative s over, cancel yung pi, 2 d. Okay. Okay? S d d d. Okay. Okay, pansinin nyo to. Dito makikita nyo rin yung Lenz's law. Okay? Kapag increasing si dB over dt, positive tong term na to. Okay, positive tong term na to. So if we had, tanggalin natin yung direction. Parang tama dito. Ayan. Okay, kung titingnan nyo, kung positive to, increasing magnetic field, the direction would be negative phi hat. So, this is actually going this way. Kukontrahin niya yung increasing na change. Okay? Okay. Let's proceed. Nakapagod, no? Nakapagod yung mga induce na yan. Okay, inductance. Punta tayo sa inductance. Okay. Suppose we have two loops. Meron kang current I on loop 1. Siyempre, magpuproduce to ng magnetic field, which is B1. Okay? And then you have another loop of wire, loop 2, arbitrarily shaped silang lahat. Okay? Then, of course, you can know the flux by using B as a var. Tama? Kasi B.dA, di ba? The flux into can be okay? Can be obtained by integrating all the magnetic fields coming from 1, B1, into the loop DA2. Okay? Bale sabihin yung DA2 ay yung area nitong loop 2. Yung B1 galing sa loop 1 yung magnetic field, of course. Okay? However, B1 is not very simple kasi arbitrarily shaped na siya, di ba? So this is actually mu naught over 4 pi tapos integral ng I dl cos r hat over r squared. And this is I1, tama? dl1. Okay, and r would be the distance between the loop 1 and loop 2. Okay, tingnan nyo to. I1, I can factor that one out. We have mu naught I1 4 pi and some integral dot. Okay? My point is that if you increase the current, mag-increase din linearly yung magnetic field mo. Okay? Okay ba yan? Kuha? Therefore, I could say that phi2 is just I1 times some constant, which is M21. Okay? Yung M21 is not magnetization. No? Nauubusan na tayo ng letters. So this is actually mutual inductance. Okay? Now, okay. What do, okay. So, now let's find out this guy. Paano natin makukuha to? Okay. V2 is just the integral of B dotted with dA to B1. So, B can be written down as the curl of the vector potential. Ooh, useful na siya. Okay. Charan. So, the dot product of this with 2. Which is by Stokes' theorem is given to me as A1, I mean, sorry, A1 dotted with, of course, DL2. Okay? So yung boundaries ng DA1, ay DA2, I mean. So we have this. Okay? We have that. Tapos, I can write down A1 as the okay, I can write down the vector potential as yung usual na natin, usual pagkuha natin 4 pi, which is I dl dl1. Okay? Sa yung vector potential ito ng A1, so kukunin mo yung loop as yung the lower one, loop 1. And then of course some distance r. That would be from the point of interest A1, and then yung r mo, yung r prime coordinates would be your loop 1. Okay? So if we plugged in this guy to this entity, we have V2 as mu naught I1. Okay, kopyahin ko lang. I1 to. Ay, hindi. Parang tayo mali to. Oops. Yung V2 ko ay integral ng cos integral ng A1 dl2. So let's write that down first. Okay. A1 dl2. Okay. And then I plug in this to here. So mu naught I1 over 4 pi, then double integral ng dl1 plotted with dl2 all over r. Okay? But we have said earlier that V2 is just some constant M21 times I1. Therefore, this tells me that kapag inalis mo si I1 dito, yung M21 would be just this thing here. Okay, and that is given by this guy. Okay? And mapapansin nyo, kapag pinagpalit nyo yung indices, kuwari pinagpalit natin yung loops, pinagbaliktad natin, loop 2 sa baba, loop 1 sa taas. Pansin nyo, it's the same. Okay? Okay? And then if you plug in, so let's write down na lang na M na lang siya. So kapag kinuha mo yung electromotive force on the loop 2, you just plug in V2 on your usual formula, you have negative M di1 over dt. Okay, so information overload na ba guys? Pagod na ba tayo? Kaya pa, kaya pa. Kaya pa, kayanin natin. Patapos na ang SEM. Okay. Now, let's try an example. A short solenoid, length L, radius A, with N1 turns per unit length, lies on the axis of a very long solenoid. So, meron ka short solenoid sa loob, tapos may mas malaki, nasa loob siya ng mas malaking solenoid with radius B and 2 turns per unit length. Okay, and the current I is in the short, meron kang current I sa short solenoid. Okay, what is the flux through the long solenoid? Okay, pag inisip natin, the field of the short solenoid is not very simple kasi it's short. And we don't know that. Alam na lang natin yung field inside would be some form of the solenoid, pero outside, it's very complicated. So, paano to? Mahihirapan tayo gamitin yung short solenoid. Okay. Paano to? Okay. So, ang good thing is, the mutual inductance, pwede mo silang pagpalitin. Okay? Pwede mo silang pagpalitin. So, in essence, pwede mo rin pagpalitin yung mga flux nila. Okay. Pero paano ba natin ito gagawin? Siyempre, gawin natin systematically, di ba? Okay. So, isipin natin na malalaman mo yung pwede ka magpadaan ng current I sa long solenoid, which is alam natin yung mangyayari. Okay? So the flux through the long solenoid can be obtained by getting the flux of the outer solenoid through the inner one. Okay, let's do that. Let's do that. Okay, the outer solenoid, ano yung B nun? B is just N2 I B2. Tama ba? Times mu naught. Mu naught. Okay, so inside B2, inside the bigger solenoid, the field is uniform. Nice. That's what we like, di ba? Sabihin natin Z hat na lang, no? Boundary, Z hat na lang. Okay? And then, ano yung flux nito through the smaller guy? So, B2 times pi A squared. Kasi circular yung, ano niya, di ba? Circular na yung length, ay yung area nun. The smaller guy. So, pwede natin gawin to. Okay? N2, so M mu naught, N2 I, and then times pi A squared. However, this is just for the single loop. Okay, so there are N1 turns per unit length. Therefore, kung gusto natin makuha lahat ng mga flux, so this is just V. The total flux would be, of course, mu naught N2 I pi A squared. Tapos, multiplyan mo ngayon ng yung kung ilang rings yung madadaanan mo, that would be just N1 times L. Okay? Given naman yung L ng length ng inner solenoid. Therefore, that is the total flux of the inner solenoid. Okay? Nice, di ba? So, you can do that. Pagpapalitin nyo yung kukunin yung flux. Okay? Okay. Walang tanong, walang tanong. Walang tanong, guys. Okay, continue natin. Funny enough, when we have a loop of wire, you run down the current You run down a current I. What happens to the field? From 0, then boom, maglalabas ka ng magnetic field. Tama, di ba? By the right-hand rule. Ganyan siya. However, this goes back towards the bottom of the loop. So in essence, pag nagbukas siya ng field, pag nag-open siya ng current, magbubukas siya ng field, and that field will also affect that loop. And we call this thing that's happening here is self-inductance. Okay, so naapektuhan mo talaga yung sarili mo kapag nagbukas ka ng current mo sa sarili mo, okay? And we call that self-inductance. So L naman ngayon. Kanina mutual inductance N. Now we have self-inductance L. Okay. Okay, so fun example. Wala tayong solve dito. Kaya fun siya. Okay. Suppose a current I is flowing around the loop, and when someone suddenly cuts the wire, what happens? The current drops instantaneously to 0. This generates a whooping back EMF, for although I may be small, dI/dt is enormous. Okay? So dI/dt, kapag meron kang steady supply ng current, we have, okay? So we have T, then I. So, steady siya for a long time. Okay? Kasi nanay mo, hinugot bigla yung wire. Siya na yun. So, that's your current. So, ano slope nito, guys? Ano slope nito? Almost infinite yan, di ba? Almost infinite yan. Kaya sobrang taas ng dI/dt. Kaya, ang mangyayari, you sometimes draw a spark when you unplug your appliances. Okay? So, yung electromagnetic induction, trying to keep the current going. So, ayaw ng nature, di ba? Ayaw ng nature ng change. So, kapag hinugot mo yung cord, ang nangyayari na mag-spark yun kasi gugustuhin ng appliance mo na mag-sustain ng current. So, hinihigop niya from the atmosphere yung mga charges. And you see, nag-accelerate yung mga charges and then umiilaw siya. So, you see a spark. Okay, now, when you look at the... okay, nakikita niyo ba ito? Sorry, tanggalin ko yung filter to. Choose the filter. Ay, huli. Virtual background pala dapat. Ayan, makikita niyo ba ito, guys? This is a charger. This is a normal charger. Okay? Makikita niyo, ito ay isang... Ayan. Makikita niyo itong big part na, cylindrical part na yan. That is a solenoid. Okay? Or inductor. So, yung inductor na yun, pinipigilan niya yung mga sudden changes in current. Okay? Kasi pag may loop ka, may extra loops ka, ang gagawin ng extra loops mo is to prevent that infinite drop of current. Okay? So, yun yung ginagawa ng mga inductors mo. Okay, going back. Okay. So wala masyadong dramatic happening kapag nag-plug in ka naman. Okay? Okay. So paano ba 'yun? Paano ba natin pag nag-plug in tayo? So we have this figure 7.35 na kapag meron kang supply, then may inductor ka, tapos meron kang resistor, then you close the switch or open mo yung appliance mo. So you know this, guys, di ba? Ohm's law lang. Okay, Ohm's law lang to. Then you get this formula. And then if you solve for I, which is very easy pa naman to do, kasi this is a first order ODE, kaya niyan. you have this equation. And when you graph this equation, you will obtain this guy. Okay. As you can see, hindi na siya abrupt ngayon. Hindi na abrupt yung change dahil may inductor ka na sumasalo or opposes that sudden change in current. Okay, however, sabi nga, pag pinatay mo nga, nagiging violent pa rin. Kasi pag pinatay mo, mag-drop siya pa ganun. Okay. If you reverse the equations here, makukuha nyo ng sagot ay ganito. Okay? So, ito ay abrupt pa rin. Mataas pa rin yung di over dt at this change in current. So, nag-i-spark pa din. But not as dramatic yung walang inductor coil na paganyan yung current mo. Ito yung violent talaga. Okay? Okay. Okay. So, tanungin natin ngayon, di pa tayo nag-energy in magnetic fields, di ba? Na last time, we have your energy in electric fields. So, ngayon, tingnan natin, no, paano ba yung magnetic fields? Okay? Suppose you have a circular circuit. Okay, may circuit ka na ganyan. Okay. And then, if you want to move the charge around, okay, may charge ka na ganito. Lagyan ko ng ano guys, lagyan ko ng supply para namang hindi nakakatakot yung meron tayong EMF na magical. So, kuwari ito yung supply mo na nagpo-produce ng tawag dito? Produce ng EMF. Then, the charge at this point, okay, if you're gonna rotate it around here, it will experience a energy, of course. It will experience a work QV, okay, which is just Q epsilon. Kasi V is your EMF, di ba? Pwede natin sulat na ganito. Okay, so that is the energy required to rotate the charge all over that circuit. Now, if we are okay, so suppose gusto mong kontrahin yung tawag dito, yung paggalaw ng current na yun, then you would oppose, of course, that amount of work, di ba? So when we have this, kunin mo yung beat, and you have dt. Okay, so kinokontra natin kaya tayo naglagay ng extra negative sign, no? Kontrahin natin yung ginagawa ng supply. Okay? We have this. We know dq over dt is just I. So, negative I. Okay? Okay. And then the electromotive force will of course be coming from this. If yung effort na ginagawa natin is totally magnetic, we have this self-inductance formula. Okay, so negative I times negative L di dt. Okay? Okay, so we have I cancels out, Li di by dt. Let's work. dw dt. So therefore, the work, integrate mo, tatanggal lang yung mga dt. So 1/2 Li squared. And that's it. Okay. Okay. Hindi kayo convinced? So, integral ng dw is just integral ng Li di. Okay? Kasi na-cancel lang yung dt. Therefore, I squared over 2. Okay? Okay, convinced na? Okay. So, paano, parang sir, hindi naman intuitive na isipin yun na, ayun yung definition ng work. Okay? So, kuwari, nagbukas ka ng EMF, it would rotate or move the charges around. Then, sabi nga natin, meron ka tayong self-inductance na sinasabi kasi babalik sa kanya yung magnetic field na napoproduce nun. And that magnetic field will counteract by Lenz's law, counteracted motion. Okay, so yung counteract na ginawa niya, yun yung ginawa natin, negative IE, I epsilon. Okay, so the work na ginawa work na ginawa niya sa sarili niya, basically, is 1/2 Li squared. Okay. So that is for your self-inducting wire. However, let's try in general to get the work na pinoproduce ng magnetic field. Okay. Let's do that. Tatapos na ba ako sa lesson? Tatapos na. Last na pala ito. Okay? Nice. Okay? Wait lang, naglalag yung Sorry. So, let's try to do this. Balik tayo sa definition ng flux natin. This is integral of B dot dA. B can be written down as del cross A. Tama? Dot dA. Okay ba yun? Tama? And then, by Stokes' theorem, we actually have this as A dotted with DL. Okay. So, phi, ano yung ginawa natin sa phi kanina? Is Li. Sulat natin si phi as Li. Bale, on a loop, what happens with the magnetic field? What does that magnetic field carries? Okay. So, we have Li. The left-hand side will be equal to the line integral of A dl. Okay, and then the work is just plug in ko si L. Okay, so plug in ko si L. So we have 1 over 2 I squared times 1 over I integral of A dotted with dl. Okay, cancel yung I, 1/2 I na lang. Okay. Nice. And then, yung DL ko, di ba dyan nagpo-flow yung current? Di ba? So, I can write this down as cross integral between the dot product of A dot I, okay, then DL na lang ito. Okay? Kasi yung direction naman ng I ko would be on the direction of DL. So, I can do this. Okay? It simplifies to this. Then, in general, if your I is now a volume current density, I could generalize this into a all space A d tau. Okay. Okay, and then I could, what do we do? J is, can be produced by Ampere's law. Del cross B, hirap naman ito. Del cross B mu naught J. Therefore, J is just 1 over 2 mu naught A dotted with del cross D, the curl of D, tama ba? D tau. And then that is a mu naught. Okay, all checks out. By this, gamitin natin yung identities natin at the back of our book. Therefore, A dot del cross B is just B dot B, and this minus del dot A cross B. Okay? Okay, so this is 2 mu naught. And then, ano yung nakuha niya? B squared minus del dotted A cross B. B squared minus del dotted with A cross B d tau. Then of course, as before, like yung sa electric fields natin, I can write this down. B squared. Iwalay natin into two terms, parang sadali. D tau minus integral of del dot 1 over 2 mu naught. Okay? Minus del A plus B. And I can use my divergence theorem to produce something that is some constant, 1 over 2 mu naught. And then the integral para sa divergence theorem is dA. Tama, di ba? And then, sige, sulat ko na rin para, okay. Ito ay A cross B. A cross B, dA, dot product. Okay. Again, as before, I can extend my integral. I can extend my integral to infinity. And we can see that this term would vanish out kasi B is 0 at infinity, A is 0 at infinity. Tapos, walang currents doon. Then I can safely do that. Tapos, yeah. Ang point is, similar construction for your electric fields na ang mangyayari ay ganito. Okay? The energy would be integrated all space, then B squared na lang. But in essence, you can always do this. If you're not very happy with that equation, you can still do this. Okay? Okay? And what's nice about that is that tingnan natin yung sa electric field. Yung electric field, ganun din. E squared, d tau. So we have that. And sa magnetic fields, we have this. Okay? Pagod, no? Pagod. Okay, so that's what happens when we move around magnetic fields, loops, currents, charges, etc. We have these kinds of things. Okay, so okay na. Ano na tayo? Sorry. Feel ko dapat pag ganito may recitation na para hindi kayo bore. Pero okay lang yan. I mean, kung nakatulog kayo, okay lang. Nung estudyante rin ako, nakatulog ako. Pero kasi naririnig niyo yung pinagsasabi ko habang natutulog kayo. Or idle yung utak. And sometimes, nare-retain natin yun. Okay, may video dito. Send ko na lang. Panoorin nyo in your own time. Okay, that's it.